Hey, welcome to our rules for drawing video 2 here. So in the previous video we talked about dividing a circle and how I'm going to use this in the future on a lot of my drawings. So I want to pick up and fill in these last kind of 3 rules that I have laid out. Starting with dividing a line, which is really related to the dividing of a circle. It's because what we're drawing are going to be a lot of round stuff, like I've already discussed. And then when we go to make a flat pattern for round stuff, obviously our sheets, when we load them into our plasma cutting table, or if we had a laser cutting table or water jet cutting table, that's always flat sheet stock that we put in there. So anything that we draw that has to be formed will be flat. And so we kind of have to visualize when we draw stuff round, for my dividing a circle rule there, that if we go to take that circle and lay it out flat, it becomes a line. And so what I want to show here is what I do was, once I've drawn something that's going to be round, I just kind of want to lay it out, the circumference of it, kind of in a line. And then I can take information that's on all these points and then have a point on a line that corresponds with where I got the information from. So the initial first start of that is we have to take, and so in this example we did a 4-inch round circle over here. So let's just stay with that, and I'm going to grab some green here. I'm going to do a line, and this can start anywhere really. But it is going to be a specific length here. So I'm going to make the length of this line the circumference of that circle over there, because even though these rules relate to each other, as we draw stuff, that's really the connection. What I'm going to lay out flat is going to be what I'm drawing. And so I'm just using that same 4-inch diameter circle over there. And so I haven't really specified what material thickness this is or anything. So really I can just do the standard circumference of a circle formula. And if I have a 4-inch circle over there, times by pi, the length of a line to represent the circumference of that circle would be 12.5664. And these are going to be in inches long. So if I do that, I end up drawing a line that's 12.5664 inches long, just a little over 9/16. And I actually want this to be a solid line, so I can change that just by selecting it, choose it just a solid line, and I'll change it over there. So what I have right here now is a line that represents this circle stretched out flat. So this is what we do. We essentially take things that we're drawing and lay them out flat. And so, but that becomes a real critical length dimension. So that's why I use the circumference of that to get that. Now, what I want on this line, and this is how I divide like all my patterns when I'm doing these kind of development works, is they just relate them to the amount of divisions that I took over there, because over in this circle we have these 12 spaces, 12 points, 12 node points that are equally spaced around that circle. So I just need corresponding spaces on this line. So I just use my same command, and I'll do these in white too, but I use my same command, my divide command here. I'm going to select this line, maybe. Sorry, I missed it there. Let me select it again. I'm gonna divide this by 12. So now, even when I'm zoomed out here, you can kind of see those little node points appeared on here, and these now become points that I could pull information off of a drawing and snap them to. So that if I had actually drawn a real drawing over here and I had information that related to point number 7 here, I could actually copy it and then drop it in place on its corresponding node point. So let's say, I could actually even number these the same way that I did my circle. And if I were to do that, if I actually select a command, it will actually show me that as I move along here, here's my node points that have popped up. And I have 12 of them. So if I went through the process here, I could actually call this like node point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you'd be like, well, I've got one more point. Yeah, you actually you're back to point 1 here. So when I take something that's round and I stretch it out flat, where they two come together are the same point. So this would be point 1, this would be point 1, and those would all be corresponding points. And then the interesting thing about that is, and I can go ahead and label that, but because this is point 1 and so forth. This would be 2, on this node point. And I could just continue to label all these for our own. But these would all have these points, and then this one I'd end up with 12 as this last node point, to where this is where my pattern would kind of repeat itself, and this would actually be point 1 again. And the idea is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, back to 1. As I take and would roll this back up around into a circle, if I started on point 1, this would come around back to point 1 again. So the ends of my patterns come together, and those are usually where my weld seams are. And really, depending on the shape of whatever I'm drawing, I could choose to put my weld seams really in any of these positions. I could start this pattern on point 4 and then just go 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, or 11, 12, 1, 2, 3, back to 4, and I would have point 4 as being my weld seam. So I know I haven't really defined an elevation to this part that we've drawn over there, but I just wanted to show you that when that circle becomes kind of a flat stretch out based off the circumference of the circle that I'm dealing with. Then I divide it by 12 so that I have corresponding points to take information. So if I had actually some height drawn in here of a part or a piece of pipe length that corresponded with point 2, I could actually like copy and paste that and snap it on to point 2 over here. And the interesting thing about looking at this is that would mean that the information that I had got from point 2 would be the same information if the part is symmetrical that lies on point 12. And so like the information from point 2 and point 12 become the same, and so as long as the part is symmetrical. And we'll get into non-symmetrical stuff to where each point has its own has an elevation that is strictly unique to its point, and that's why I always have to be aware of all 12 points, especially when I go to the circumference. So that's a brief overview of how I lay out my circumference lines. They'll have the same divide by 12. The ends of my lines become the points where the pattern will come back together on itself. So, and I have control over where I start and stop that pattern. All right. So let's move over a little bit and talk about bisecting a line and bisecting an angle. So these are two other rules that I just want to briefly discuss here, and they're going to be some stuff that we use. So let's take a shorter length line here, and this. So I related this dividing a line back to this dividing a circle line. I'm gonna, as I bisect a line, this is going to be non-related to what I've done over here. So this is kind of its own unique little rule for any line here, though. So let's take a line, and I'm just going to draw this any length. I didn't even pay attention to what length that was. I'm going to change that to a solid line, though. I'm going to draw in solid lines here, so go ahead and change my command to a solid line command. Okay, so what I have is a line, any line. I'm just going to show you like a little trick. AutoCAD makes it easy, and you can input the divide on that, and it would find the center of that for me. I could even choose the snap to midpoint command on my object snap settings, and if I'm at midpoint, I can actually find the midpoint of that. But I just want to like remember that I'm also drawing lines with rulers, straight edges, and compasses. And let me show you kind of a compass trick on how they would bisect a line to find the midpoint, because we can do that too here. What I'll do is I'm going to change to a different color. So let's say I have this line. I need to find the midpoint. What we would do with a compass, maybe and we could do this on our shop table out in the fab shop. But I could set a compass up, and they make compasses that are beyond just those small handheld ones like we have on the tool boards. You can actually make your own, like really a super long compass, you know, with a piece of round rod or something, and be able to have a point on one end and a marking tool on the other end. And you can, in some of the fab shops I worked in, we had some of these set up to where we could mark some big circles, 4-foot diameter stuff, 5-6-foot diameter stuff. And so you can make your own tooling to do that kind of stuff. And but to find the center point on a line, obviously you could use measuring tape too. But here's like a little trick of compass tricks that a drafter maybe would use, an old layout guy. So all you have to do to find a center point is come to the end point of the line, and you would be making an arc that's like over the halfway point of the line. So like this actually would have me snap to the midpoint. If I didn't know where the midpoint one is, I can usually eyeball or visualize like scribing an arc that's beyond the halfway mark. Alright, and then once I had my compass set to that radius, which I can do with a simple copy command, like copy the circle. If I had my compass set to that radius, I could just come to this end of the line and then snap that same arc. Obviously in AutoCAD we're getting full circles, but if I was actually drawing this with a compass, all I would do is like put the center point on the end of my line like that, and then just like come out here and like make sure I'm over halfway, and then just scribe just a little bit of an arc out here. And it would just be just a little bit to where I think I'm going to intersect it when I come to the other side. Because what I'm looking for is these points of intersection here. So this point of intersection and down below here. So I would have taken that radius and scribed an upper mark, and then come down here and scribed a lower mark. And I would have done the same thing with the same radius off the end of the line and scribed these two where they cross, and I would have had to make sure that they were going to cross each other. And then these 2 points of intersection become, if I take a new color and take a line, these become a line that bisects my initial line. So using circles in this case, or a compass with a little tick mark off my compass, I can actually find a line that bisects an existing line. And this becomes handy as I'm drawing to find midpoints quick of lines, and that's kind of a little compass trick there. So I'll leave that one up, and maybe I'll move this here. I'll just move this over this rule here. So that was my bisecting a line rule. Last one I want to look at here, I'll move it out. He's getting kind of big, but I'll move it out and up here. We're going to bisect an angle. So, and it's very related to what we just did. And this just becomes handy when I lay out piping offsets. And so really dividing a line, I don't use a lot, but dividing an angle we will definitely use. And it's because I'm still using compass little layout tricks and not necessarily being totally dependent on AutoCAD to give me all the answers. So, even though it will. And there's nothing wrong with having shortcuts. I just want to show you some techniques that I might use on my shop table too. So, for bisecting an angle, let's take and establish just an initial angle. And I'll just do like a 90-degree angle here. Maybe I'll do a 90-degree angle, and then I'll do something more related to like a pipe offset. So let's just say I take, let's just say, let me undo that actually. I'm going to delete this. Let me pick a point here, and I'll just draw like a 4-inch long line this way, and then I'll draw a 4-inch long line this way, and I'll escape. So now actually I have a 90-degree angle that has equal legs, and I'll show you why that is. I need to know like equal distance from the point of the angle. So I kind of have to be aware of that. That's why for this exercise I've made these both 4 inches long. This would be, I mean, if these legs were any length, it would be fine. I would just need to pick a spot that's equal distant from this corner on this leg and on this leg to do what I'm going to do here. So this makes it easy because I can snap to the end of the line. But what we want to do, we want to bisect this angle. Bisecting means I'm going to just cut it in half. And so in this case, it's going to be, you know, like a 45-degree angle coming down because this is a 90-degree. We can see that. And so let's do this one first, and I'll do. It's a very similar thing here. What it is I'm going to come out a set distance from the angle that I'm looking to bisect. In this case, it's 4 inches. And what I want to do here is kind of eyeball like something beyond where I think the center line coming through there is. So this can just be an eyeballed, just an arbitrary length here. I just know that maybe this is the center, and if it's a 45, and I'm going to bisect this. So maybe this is just a little bit beyond, and I snap that circle. So it's beyond like an imaginary line that would be coming through here that I'm trying to establish. So there is one circle, and then let's take, and I would have a compass set up that same radius, or I can just copy that circle. And then here's the trick, you know, is that I have to be the same distance from the corner to that center as I do this other circle, which I've established the angle I'm bisecting to be the same. And so now I've just come 4 inches out this way and 4 inches out that way, snap these circles that are over halfway. And now a line drawn through here should bisect this angle. And so let me just go back to a blue line, and yeah, so if I had this line and I pull it beyond here, I'll just escape. So it should be, as I zoom in here through this, where these circles came together, if I drew my line through there, it should, I'll zoom out now and zoom in on the corner angle, it should have bisected this line completely in half. So now we've got two 45-degree angles here. And I've just used this rule of bisecting an angle to find that line without doing any math, without doing any other commands with AutoCAD. I can just snap a couple circles, eyeball them, and have this angle bisected. So where this comes, you know, in handy, let me kind of do another one. And maybe I'll do one that's not like a 90-degree angle, maybe something more like a pipe run, which might be something like, I don't know, I don't even want to really see what the angle is. Let's just make it like some oddball angle, and then it goes like this. And now I'm just going to actually make a run up this way. So what I've drawn in here is kind of these two, I mean, this is just like, I almost visualize this as like center lines on pipe. So this is just a mini example leading us to maybe one of our first lessons. But I've just got like, if I view this as like a center line of a pipe, and I don't know what the diameter of the pipe is, I'm not worried about that. A lot of the times when we do pipe, we run by center lines anyway. So this is just like a pipe run coming in this way, and then it turns and goes this way so far, and then it meets up with another pipe run back into like its parallel. And it has this little offset jog in it. So, you know, if I were to like make this out of pipe, it would need to be mitered to do that. And I don't just anything that, you know, whether it's square tube or round pipe, I don't just miter one side and then run the other side like 90 degrees to that. I've got to share the miter on stuff. They have to be equally mitered so that the particular part lines up and you have a nice weld joint. You can't just put all the miter on one side because mitered lines are longer than just straight 90 cut lines. And so where I would use this rule that I just established here is maybe I need to bisect this angle, from this line over to this line. And I could look at it from this side, or I could look at it from the big side, way past 180 degrees here. And so to do that, I can use the same kind of rule here, like I can use the same rule in that I need to, I don't know what these lengths are. This time I wasn't very accurate in making the length of these lines. They're all kind of different. I never even paid attention to that. So what I need are, from this point, I need kind of equal distance spaces down both of these lines here. And so what I do is I'll just take a circle of a known, and I don't even really have to pay attention to what this is either. If I just take a circle and visualizing that I would set, a compass at a radius, and I could make a mark on the, let me just pull this out like this. So all I've done is snap a circle using this as the center point. That establishes a point out on this line that is the same space as the point out on this line here. So now where these cross, they're the same distance from the center point here. And that's the point of where my angle is. So now I've kind of established, what I visualize is that this point out here and this point down here are kind of like these two endpoints of this angle here. So in that they're the same distance from this point here. I've kind of done that here, only this is not a 90-degree angle. So I've used this other circle just to kind of establish these points. And now what I want to do is I'll even use like a fourth color to do this. But now I have like an additional set of circles here. And what I want to do is I visualize that these come together at this angle, and maybe if I eyeball this miter would run kind of in this direction. I can kind of visualize where that would be. So this is the same. I just need to pull a circle that maybe is going to be out here where they'll cross that line. I don't know where that is, but maybe it's out here somewhere. I just pull this, and I'm using this as the center point because it's equal spaced off this miter. And it ends up, and I'm just visualizing that this point comes in here somewhere. This miter line would come in here somewhere. So this point out here, I know is kind of like intersecting it. And then I can copy this circle. And these are only reference circles, really. And it's going to be from that center point. I'm going to use this one here and paste it there. And see, what it's done is it's established these points where they cross that should pass through this point, and they would be equal mitered on both sides. And so really these are like reference, a lot of times I told you I like to have these as like reference lines. They're only used to reference. The magenta colored lines their centers are off of where the green and the white lines intersect. And then they've established me this new miter line. So if I make it a different color here, it's going to be, and I'm snapping to these intersection points. So now I've bisected that angle. Both sides, whether I'm looking at this side of the angle or I'm looking at this big side of the angle, this line has bisected both, just using the rules that I've done here. Because here's my one point way out here. I'm going to zoom in on the center line here. It's passing through that angle that I was looking to bisect. That's critical. And then it is back out here. So this, if I kind of zoom out, and then I could change these now. Sometimes I'll use those as a solid line while I'm making my miter line, and then I can change them to just a reference line. I can even we'll work with moving stuff to layers in our lessons. And I can put these reference materials in a layer and turn them off and get them out of my way, because really what I'm looking to do is I'm just looking for a miter line that is bisecting this angle here. So now if I visualize that this was pipe, I would have like a miter angle for both of these. They would share this miter angle, and then they would line up to be an accurate fit up, nice for a weld joint. So that might be a little foggy on you still. I just wanted to kind of present this rule right here, and we're going to come back to this. So you have this video to kind of reference how I bisect an angle and how I actually do that in kind of in an offset angle like this. So I could do this task and then turn these off to another layer. And how I would do that is, we have up here we have layer properties, and I don't know if we've used that a lot with our other drawings, but we're going to start using that a lot just to turn things off and on that I don't need. But I don't want to just delete them, because I want them as reference material. So if I bring up this layer properties box, it gives me, I'm only on a single layer right now. Everything that I've drawn is just kind of on it's on like one sheet of paper. So now I want to add some sheets of paper. So I can just do that, and there one pops up as layer 1. So I can just X that out now. So that's how I added new layers, and I can delete layers here and freeze layers so that I can't turn them on and off. But then there's a quick drop down tab here that shows that new layer that I added right here. It shows that, you know, I've got it turned on, and I don't have it locked. It's unlocked, so I can freeze it, unfreeze it. So what I can do here is I can actually choose this reference material, select all of it, and then I just right click on that. Brings up a kind of a properties tab, and if I go down to properties, it brings up the information. And over here on the left side, it shows me what my color is. I can change everything at once here. I can push things to a different layer. So if I've drawn stuff on the wrong layer and I wanted it to be on a specific layer, I can just choose this, and I can push it to layer 1. And that's what I've just done. I've just pushed it over to layer 1, and then I can just X this and escape from that. And now when I bring up this layers tab, if I don't want that reference material on, I can just turn that off. And now I'm back to just simplifying my drawing, kind of cleaning it up. And so I do this a lot with my drawings as I go from step to step and things get cluttered. I just turn them to another layer and then turn them off. And so you'll see me use that a lot, and I'll continue to explain what I'm doing there. I just threw that in as kind of a bonus rule here, is that you'll see us using layers. I can name my layers whatever I want to do, whatever I want them to be, and I can just leave them just layer 1, 2, 3. But, you know, now in the case I could like start to actually draw something around this miter. Maybe it's some 4-inch pipe, you know, and this is the center line, so I'd kind of come out 2 inches this way and 2 inches this way, and then they would kind of come up and meet that miter line. Then I could come off this line and come out 2 inches, and I could use my offset command to do that. Offset, you know, 2 inches, 2 inches. I could get these lines hitting that miter line, and then they would have an equal shared miter. So we'll see more of this. In fact, in lesson 1, we're gonna look at a miter line. I think it's actually lesson 2 where we start to do some piping offsets, just to kind of use bisecting an angle and some of the new rules that we've established. So that's all I've got this time. I think from here we're going to a lesson 1 and do an actual drawing with a flat pattern development. And so we'll catch you there.